Alright, class. I had mentioned in class that I would solve the problems that are in the back of Chapter 1 in the Key Skills section in class. Well, evidently I lied to you because I just went straight on to Chapter 2, going to Chapter 3 without it. So what I'll do is I'll solve the Key Skills problems in these videos and I'll put them up online. Alright, so we're going to start with the first one, problem 1.1 at the end of Chapter 1, Key Skills area. And the problem states that given the density of gold is 19.3 grams per centimeter cubed, calculate the volume in centimeters cubed of a gold nugget with a mass of 5.98 grams. Right? So, the way to approach and solve this particular problem, let me zoom in here a little bit so you can see this just a little bit better. Alright, given that the density of gold is 19.3 grams per centimeter. First thing we're going to do is we're going to start with 5.98 grams is what we have. That's our first piece of information. So I'm going to write this down in our cross diagram. 5.98 grams of gold that we have so far. Now the next thing we're going to do is do our cross diagram here, and we'll see what we've got in the cross diagram. We've got 19.3 grams per centimeter. Now there's two places to put that. If I put 19.3 grams up on top, the grams become squared. So we don't want to do that. So let's do 19.3 grams per 1 centimeter cubed. Okay? And what we are looking for is the volume, and volume is a cubic measurement. So that's centimeter cubed. Right? Easy enough. One-step problem here. So, get out the calculator. Alright, let's put this so we can see it. There we go. Alright, 5.98 divided by 19.3, and that gives us an answer of 0.3098. Okay, so I'm going to write these numbers out. Do 0.30984456 centimeters cubed. Now if we look at this, we want to say, where do our significant figures lie? I've got 3 sig figs here. I've got 3 sig figs here. So as a result, this thing should have 3 sig figs as well. So 1, 2, 3, there's our sig figs. And this fourth one, we're going to round. So let's round that. So our sig figs are going to be 0.310 or 3.10 times 10 to the minus 2 centimeters cubed. And if we look at our answers, we've got letter D would be the answer to that. So D is the answer there for problem 1. Alright, for our next problem, 1.2, the SI unit for energy is the joule, which is equal to the kinetic energy possessed by a 2.00 kilogram mass moving at 1.00 meters per second. Convert this velocity to miles per hour. Okay, so in this one, we've got two different pieces of information. We've got a 2 kilogram mass up here. They have 1.00 meters per second. But the 2 kilogram mass is not entirely important to this problem. Okay, all we're asked to do is convert this velocity, which is this, into miles per hour. Okay, so I'm going to set this up 1.00 meter per second, right? And I'm aiming for miles per hour. Okay, that's our target for this particular problem, miles per hour. Right, so let's set up our cross diagram. The first thing I'll do is I'll convert time, since I don't have to look that up, and I can just talk about it right now. And I know that we're looking for hours at this point, so I know that we have 60 seconds per 1 minute. And I know that this is set up correctly because seconds will cancel. Alright, and I know that there are 60 minutes in every 1 hour. Okay, at this point, minutes cancel, and I've got my hours set up. Okay, Now what we have to do is we have to convert things over to kilometers and miles. All right. And if I use the back of the book, I know that we have, well, first I'll convert to kilometers. So I know that 1,000 meters is 1 kilometer. And I also know that 1 kilometer is equal to 0.6215 miles. And that's not a definition, okay? So I've got 4 sig figs there. Okay, now I want to make sure that all my units are correct. Okay, so I've got meters canceling out at this point. I've got kilometers canceling out, so I'm going to have miles per hour over here as far as in my units. Okay, so now it's just a point of plugging this into a calculator and working this through. So let's see, 60 times 60 times 0.6215. I do everything on top first, and then divide by 1,000. And what I end up with is this number, 2.2374 miles per hour. All right. Now, is that the right sig figs? Okay, this is a definition. That's a definition. Okay, this is a definition. So all of those have infinite numbers of sig figs. And I've got miles up here and this one over here. So this one's actually got 3 sig figs, and this one's got 4 sig figs. So I've got it limited to using 3 sig figs. So I will convert these two numbers. I can round those up. So this becomes 2.24 miles per hour. And if I look at the actual answers, I've got the last one, E, is going to be the answer for that. So there you go, 1.2 solved. Now we're moving on to problem 1.3. And here I've got a density problem. It says determine the density of the following object in grams per centimeter cubed. A cube with an edge of 0.75 meters and mass of 14.56 kilograms is what we're going to be using for this particular problem. Since I have 0.75 meters and I'm looking for grams per centimeters cubed, the trick here is to recognize the fact that I have to do a conversion between meters and centimeters. There's 2 places you can do that. You can do it at the beginning of the problem, where you have meters to centimeters, or later when you go to meters cubed to centimeters cubed. All right? The first thing I'm going to do is I'm going to show you how to do this just using regular old meters. Okay? So I've got 14.56 kilograms listed here. All right. The next thing that we're going to go into is meters. So I've got 0.750 meters. And the easiest thing to do is convert that. 1 meter is equal to 100 centimeters. It's the easy conversion. Okay. Meters cancel out. Now I have kilograms per centimeter as my list here. Now I want to convert kilograms over to grams. And I know that 1 kilogram is equal to 1,000 grams. Now there's one thing that you need to be aware of, and this is that it's a cube. It's a volume problem. So I have to put this into 3 dimensions. So I've got to take the values that I've got here for centimeters, and once I do that, I've got to cube the system. All right? Another way of approaching this problem is to do it this way. I can take the 0.75 meters and I can start by cubing that. Okay, so that's going to cube my meters. And then I've got to be able to convert that over into centimeters. So I know that 1 meter cubed is equal to 100 cubed centimeters cubed. And that's another way of doing this particular problem. Okay? But I'm going to do this one up on top and show you how we solved that. So we've got 14.56 times 1,000 divided by 0.75 times 100, and I'm going to cube this value. And what I'm left with is 0.0345 grams per kilogram. All right, and that just happens to be answer A. Our last problem here is a little bit of a poser because it's worded in a very cumbersome manner, right? What it states is that a 28-gram child can consume a maximum of 23 children's acetaminophen tablets in an 8-hour period without exceeding the safety limit maximum allowable dose in milligrams per pound of body weight. Okay. Given that each child's tablet contains 80 milligrams of acetaminophen, determine the maximum allowable dose in body weight for 1 day. Okay. So we have some information. We know that 23 tablets is maximum, so I'm going to write it down here. 23 tablets, okay, in a 24-hour period. I'll put 24-hour period here, okay. That's a maximum dosage, and I know that there's 80 milligrams of acetaminophen in every 1 tablet, okay. Oops, I made a mistake. That should be 8 hours, not 24 hours. I'm sorry. All right, and it's asking for the amount per 1 pound per body weight per 1 day. All right, so I've got 23 tablets. We've got this number of milligrams. Okay, the next thing that we want to do is we want to convert this over into the right time frame. So I'll put 24 hours for every 1 day here. Okay. Now at this point, if we start canceling some units, we now have the proper number of milligrams of acetaminophen, and I've got 24 hours times that 24 hours, and I've got 1 day. So it's right now it's milligrams per day is our unit. Okay. But I want to know per pound of body weight per day. Okay. And originally in the problem it said a 28 kilogram child is what we are worried about. Okay, we need to convert that over into pounds. So that's going to be 28 kilogram child. Okay, and the ways that I put this down on the bottom is I've got a milligram per pound. So it's got to be mg per pound is my final unit here. Okay, so that's my target. So how many kilograms are there in a pound? That's a good question. Now if we look in the back of the book, 1 pound is equal to 0.4536. So I'm going to write this way, 0.4536 kilograms for every 1 pound. Okay, I did a little shortcut. What I did is I took the grams here and I converted it to kilograms by dividing by 1,000. All right, and now what are my units? So I've got milligrams of acetaminophen per day, and I've got kilograms here, and I've got pounds. All right. So now all we have to do is multiply this out and see what we get. So we do the top first, and I get 23 times 80 times 24 times 0.4536. And my top here is going to be 20,000, 30.976. I'm not including any sig figs just yet because I want to save that for the end. All right. Then on the bottom, I've got 8 times 28, and everything else is 1, so I've got 224. Okay. Now I'm going to go ahead and divide 20030.976 divide by 224, and my answer that I get here is 89.424 milligrams per pound per day. Okay, Now, because this is a kind of a complicated problem, I'm going to go back and double check that I've got everything right. Okay, so I'm going to go back and look at what I've done. Nothing has to be squared, nothing has to be cubed, anything in that manner. Okay, what about sig figs? This is a measured amount, not a definition. Okay, this is a definition over here. 28 kilograms, that was given in the problem. Okay, so that's a measured amount. This one over here, this has got 4 sig figs. Okay, this is a measured amount. It doesn't say exact next to it when I look at the conversion, so I know that it's not an exact amount. And 23 tablets over 8 hours, that's all measured. Okay, now I'm going to say that's 8.0 hours. It doesn't say that in the book. If that's going to be a measured value. So again, if the book had put 8.0, that would have been better, because right now technically we're supposed to use 1 sig fig, but I'm going to use 2 here. All right, so we're going to use 2 sig figs, 4.24. We'll write it round down. So I'll say 89 milligrams per pound per day, and that would be the correct value for this particular problem. Now, if you look at what we have in the problem, actually they do use 1 sig fig, so 90 milligrams per pound. Okay, so there you go. So they do use 1 sig fig, and they use 1 sig fig because of the hours that they've got there. Okay, a little sloppy. If they did 8.0 hours, it would have been a lot better. So the correct answer for this particular problem is going to be B. There you go.